in a small facility on some shelves, and it's a whole other thing to scale up to the size that we're at. So this gives you an idea of what we bring to the plate. I'm just going to go through this real quick. So this is Nanochloropsis. This is a genus of algae, very popular. It's a green algae, very small. We call this product Nano 3600. That 3600 basically means that this 1 liter bottle is equivalent to 3,600 liters, which is almost 1,000 gallons, of live algae at 100 million cells per milliliter. So instead of growing 1,000 gallons of algae, you can just buy this bottle and feed it to your neighbor. And so that's how concentrated our products are. The way we harvest it is proprietary. I can't bring it up, but there are people that use our technique, our method. So the way we harvest it is we concentrate the cells, we try to exclude all of the growing media, and then from there we put it in our proprietary formula and we package it. And so we are able to concentrate it down to many billion cells per milliliter, per cubic centimeter. So there are 68 billion cells per milliliter in that product. You cannot achieve that with a live algae culture. It's impossible. So we'll talk a little bit about, let's say you're an oyster farmer and you are somebody who wants to get into oysters and you're looking at, what do oysters eat? What do I need to do to grow oysters? Because these are some of our customers. And so oysters, there's all kinds of papers. You can go to Google Scholar and find tons of papers on this subject. This is just one I randomly plucked. Because these guys went out and looked at the Crassostra agagus, and they looked at them in nature. They did surveys over the whole year, and they found that these animals were consuming diatoms for some of the year. They were consuming dinoflagellates at some times of the year, other species of phytoplankton. And so, this kind of work is really helpful because then it helps us figure out, what's required, what's appropriate to feed these animals in an aquaculture setting. And so thankfully all this research, a lot of this research has been done by people that are just working in aquaculture, people that are studying it, researching it. And so we were able to kind of dwindle it down to some of the species that are really appropriate, really required to grow bivalves, shellfish, feed the life feed organisms, things like that. So this is from Cornell. They're up in New York. This is their cooperative extension marine program, which is in Ithaca. And so here you can see these are oyster larvae. So this is on a Sedgwick rafter counting chamber. So that square that you see, those lines, that's a millimeter. Square. And so a millimeter is the size of basically a mustard seed, a mosquito egg, a sewing needle tip. So that little square is equivalent to those size things. So you can see how small these animals are when they're very young, still 8 days old. And then you can see here that they're starting to mature, umbonate. I think that means having rounded or convex form, and just starting to look like they should. 13 days, they start getting an eye spot. They get that little foot so that they can kind of crawl around, and then they figure out where they want to set, and then they settle down, and they put in these little shell chips into their vats, and put them in there with the larvae, and then they start moving around, and they finally settle down, and then they start growing into a proper oyster. Yeah, you can see here that some of them already settled, and others are still kind of searching around for that sweet spot to settle down. And then once they set, then you can move on. So it's kind of neat. And then here's the end product. Those are some huge oysters. This is Taylor Shellfish Farms. They're up in Washington State. They're one of our customers. They feed our phytoplanktons to their oysters, and then there's the oysters on the plate at the restaurant, and you complete the cycle, so to speak. Okay, so let's get into phytoplankton. Okay, phytoplankton, what is it? Well, we also call it microalgae. These are microscopic plants, essentially. Phytoplankton meaning drifting plants. Because plankton in Latin means drifting, or drifting, wandering. There are over 100,000 species of phytoplankton. I didn't even know that. I looked that up recently, and I was just blown away by that. Considering that we use a tiny fraction of what's available in nature. There's phytoplankton in virtually every aquatic environment. They are the first trophic level. They are the primary producers. These things produce things like fatty acids, vitamins, carotenoids, these things that animals cannot synthesize. And so that's why they are a great food source for animals that consume them. And we'll talk about the animals that consume them. And thankfully, we've had phycologists. So phycology is the study of phytoplankton. And so there have been a handful of phycologists over the centuries, over the decades, that loved this subject and really focused in on it and helped to identify phytoplankton and helped to disassemble these cells and figure out what's inside, what makes them tick. And so we're very thankful to those folks that did all of this work for us. And working with a phycologist was quite interesting. It's just amazing what these guys know about algae. And then you can see here, this is kind of, it gives you an idea of, where the primary producers are as far as what eats what out in the ocean. And so, they're at the bottom, and, herbivores and zooplankton and filter feeders eat the phytoplankton, other things eat them, and so you work your way up to your apex predators. And so there's a lot going on. There's a lot of important aspects of phytoplankton that they provide in nature. Phytoplankton also gives us a lot of oxygen. A lot of the oxygen you're breathing right now comes from phytoplankton in the ocean, not just our terrestrial plants. So this is a great little slide to kind of give you an idea of size of things. And so when I talk about micron, this will help you kind of get an idea of when I speak in microns. So a micron, there are 1 million microns in a meter. And so bacteria are going to be bigger or about the same size as the phytoplankton we're talking about. Blood cells are larger than these things. Smoke particles, white blood cells, the limit of visibility, which is about 40 micron. That's about what the naked eye can see. And then you get into larger things. So we use a microscope at our job. We look into microscopes routinely. Sometimes they make me crazy and turn me into a skeleton. This is kind of necessary in our job to look at the phytoplankton, to see how it looks, to see if there are any contaminants. If it's motile, is it swimming properly? Does it have its flagella? Things like that. So we use a hemocytometer. This is similar equipment that people use that look at blood. There are Coulter counters where you can put the sample in just like people look at blood cells, and you can look at algae cells and count them that way. So you need a high magnification microscope to do this work, and it's a very powerful tool if you're ever going to grow phytoplankton, is to have a microscope. Okay, so nutritional profile. So phytoplankton, we always talk about lipids and proteins and carotenoids, sterols, all these things that are in phytoplankton, and these are all really good sources of nutrition. DHA is something that a lot of people bring up. Docosahexaenoic acid, that's its molecular structure there. That's very popular. That's very needed by people in marine aquaculture. This omega-3 fatty acid is very important for a lot of things: brain development, mucus development, all kinds of other things are helpful, are processed with DHA. And then these things, the phytoplankton, they produce proteins, carotenoids, which give them the pigmentation, sterols like cholesterol, carbohydrates, and vitamins. And a lot of these things are incredibly unique per species of algae. So as far as like the DHA, omega-3 fatty acids, they're important for like reproductive health, nervous system function, cardiovascular function, hair and skin, and in mammals, immune system, and so on. So getting DHA into your marine organisms is a very good thing for a lot of those reasons. Okay, so we're going to talk a little bit about some of the algae species. So this is the Lasiosira pseudonana. This is a diatom. Diatoms are very common in nature. This is one that was collected in a variety of areas: North Pacific, Mediterranean Sea, North Atlantic, Indian Ocean. This species is pretty much found in a lot of places on the globe. You can almost call it a cosmopolitan species. And so this is an excellent food for bivalves, from larval to broodstock. It's high in the fatty acid, omega-3 fatty acid, EPA, and it's also got a DHA profile. It's just a really weird looking thing. It's like a barrel or a hat. They call it like a hat box. And depending on how you look at it, it either looks round or like that hat box thing. This is only about these guys are only about 5 to 7 microns in size. And this is one of the smallest diatoms that we know of and we have our hands on. And then you get into T. isochrysis, lutea. So this is another very popular golden brown algae that's used in aquaculture. People use this in bivalve aquaculture, shrimp aquaculture, growing live feed organisms like copepods. They do really well on this species of algae. This was collected in Tahiti. That's kind of why it's called. They changed it to T. isochrysis, because it used to be Tahitian isochrysis, and then the taxonomist says, let's just put the T there and put it in that. And so that's where this was discovered and isolated. Oh, I also have these CCMP numbers on here. There's a place in, I think it's Connecticut, that has, it's like a bank of phytoplankton. It's like a seed bank kind of thing, where they have phytoplankton, single species strains that are AZA, completely clean, and they sell algae to people all over the world. And so if anything catastrophic happens to our facility, we can rely on them as our backup. And so they just asked us, to put their number on there, and you go to their website, you type that in, and that'll tell you where that species of algae was from, if it's difficult to culture, what are its proclivities, what are its needs in culture. So you get a lot of information from these folks. I think I have the website listed somewhere on here. And then we get into Nanochloropsis oculata. This is one of the most common ones. This is what a lot of people, when they start growing algae, they'll play around with this one because it's very hardy, very easy to grow, and tends to avoid contamination. Even if you get other algae in there, it tends to just box them out. They can't compete with this one. This is the smallest one we work with. This is 1 to 2 microns, so incredibly small, way smaller than blood cells, things like that. And this one is non-motile. So if you look at it under a microscope, a live algae, a live cell versus a dead cell, you wouldn't really know the difference because there's no motility. It's just not moving. Some of the algae do have motility, like the T. isochrysis. They can actually move around. They have little flagella. And this one, Tetraselmis, this one has, I think, 4 flagella and can swim very fast in the water. It actually corkscrews. So if you look at it under a microscope, it's actually remarkable to see. This one is widely used by shrimp farmers. It helps to prevent zoea syndrome in larval shrimp, which is something that plagues shrimp hatcheries, and we're talking food shrimp. Great for bivalve larvae past day 7 because this is a actually large algae compared to all the other ones we work with. This one measures about 10 to 12 microns. It's great for green water as well. So people working with larval fish and fish hatcheries will put this in their larval rearing tank, because not only will the live feed organism eat it that's in that tank with the fish larvae, the fish larvae will also eat it and gain nutrition from this phytoplankton. And so this is one this is like, a lot of people call this the miracle phyto. It just has a lot of properties that are very interesting that have very unique results in aquaculture. It also has a compound called taurine in it, which has been found to be very useful when raising larval fin fish. And then you look here, this is something that we do. We provide blends of species because there are shellfish growers and shrimp people that would like to throw everything at their end. Let's just take all the algae that are good for them and combine them. And so people said, just do that for us. And so we did. So this is our shellfish diet formula, and you can see here it's just got all the cells all jumbled together. And as you can see, these cells are not alive, but they're not all broken up and destroyed. The way we harvest them is that the cells do not get damaged. There's no lysing of the cells. They don't auto-digest themselves. There's no enzymatic action. The cells are basically, they're dead, but they're not decomposing. And so all that nutrition, all those things are still locked inside of the cell. And in fact, these cells can be used in freshwater aquaculture because they're not alive anymore, so there's no osmotic issues. There won't be any, a quick osmotic shock that causes the cell to literally explode. And so since the algae isn't alive, you don't have to worry about that. The other thing that the people that buy from us love is that the algae is contamination free. It's not live anymore, and we freeze it, and that essentially takes care of all the contaminants. And so we actually get our algae certified, we get it tested, because some nations require it. We sell to Australia, they require a phytosanitary thing where it's a certificate, there's no shrimp diseases in this algae, there's no coliform, things like that they're very interested in. So we get it all tested before we send it out. Okay, phytoplankton consumers, important to us here and to people in aquaculture. And these are just, there are many things that are under these different headings. Bivalves, consist of oysters and clams and mussels and things like that. So there are people that are using phytoplankton in those sectors. We get sponges and tunicus in our aquariums. Those things love to eat phytoplankton. Shrimp larvae do really well with phytoplankton. Food fish, shrimp larvae. I'm sure that marine ornamental shrimp larvae would benefit. Zooplankton, you can culture rotifers, copepods, amphipods, isopods, all these live feed organisms with phytoplankton. Corals, non-photosynthetic corals, gorgonians, things like that, will benefit from phytoplankton as a food source. Worms, like the feather duster worm, they do really well with phytoplankton feeds. And then, of course, larval fish. There are some larval fish that will consume phytoplankton. So yeah, there's a lot that can be done with phyto, and hopefully, some of this inspires people in this room to kind of take on some of these things. Okay, so now we're going to do a little fun, a little Pictionary. So that's a oar, and that's a foot. Can anybody tell me the Latin equivalent to that? That's my next subject. It's a copepod. The word copepod in Latin means oar, foot. So, I don't know, these people come up with these things, whatever. It doesn't look like an oar to me, but and then pod means foot. So, there's people that, say, stop using the word pod because there's so many different pods in the, out there, and so I'm going to continue to use that sentence. Sorry. Okay, so we'll dive right into copepods. So I really like working with these animals. In fact, I named one of my kids after them. So this is just a meme that a friend of mine, Gordon, really came up with. It kind of testifies to my love of these animals, and I love growing them. I love talking about them. I love inspiring people to work with them. And go out and collect them, go out and identify them, things like that. I obsess over these animals. I have to look at their cultures every day. Sometimes it drives me crazy. It turns me into a caveman. I like to dress up for Halloween. And I'm emotionally linked to my cultures. Like some people I know that are in this business. Things are going good. I'm stoked. Feeling good, and when they're not, I'm bummed. I'm mad. So it's the nature of working with living things, as you all know. You can only do so much, and life just throws curveballs at you, and you just got to be able to deal with it. Hopefully you can predict it, but sometimes you just have to react. Even my wife took my infant son's feet and turned them into copepods. She even went along with the madness. So they're pretty cool. I told her, like, it's just whatever. So I have tons of these memes. I can do these all day, but I'll spare you the torture. So now that we got that out of the way, so copepods, we'll just talk a little bit about copepods in general. So subphylum Crustacea. So a lot of you are familiar with that word, crustaceans. This is this huge group of lobsters and shrimp, and crabs, amphipods, isopods, krill. A lot of different things fall under this subphylum, including copepods. And so these are interesting animals. They're one of the most abundant animals on the planet, next to worms. Maybe worms are more cool. They're found in every freshwater and saltwater habitat. These things are even found in mountains. They're found in bromeliads, in rainforests. They're found in puddles, in deciduous forests. It's just remarkable where they can be found. They have multiple life stages. They molt, like lobsters and shrimp. If you have finger shrimp, you see them molt in your aquarium. Copepods also molt. Some are free living, while many are parasitic. We only work with free living ones, obviously. A famous parasitic copepod that a lot of people are familiar with is the Greenland shark. Has a copepod that attaches to the Greenland shark's eyeball, which is just a bizarre thing. And this copepod is massive. And it just attaches itself to the eyeball, and the Greenland shark just goes about its business. While other parasites, there are even coral parasites, copepods, that are parasitic to corals, which can be a little scary, so dippy corals. Copepods are phytoplankton consumers if they're free living. They're a vastly important food source for numerous animals out in these aquatic habitats. And now, thank God, they're commonly used in aquaculture. It's awesome. There are way more people now culturing copepods than there were 25 years ago, because they're better educated. They're taught how to do these things. A lot of these people are better at growing algae, which is fed to the copepods. And some people go to school to specifically learn how to culture live feeds. There are schools that you can, learn these things specifically. You don't have to take a whole bunch of other stuff, other courses. So it's just it's a really cool animal in many ways. And then here, I'm just going to go over some of these things. So the harpacticoid copepods, that's your ticker pods. These are mostly coastal creatures. They live in tide pools and coastal zones and splash pools, things like that. Then there's the calanoid copepods, which are open ocean. They're out in the ocean, just drifting around, part of the plankton soup. And one that we work with is part of the Calanoid crassus. And then the cyclopoid copepods, which they're pretty much everywhere on every continent. And there's freshwater varieties, there's estuary varieties, there's full salt water. We work with Cyclops panamensis, which has populations in freshwater zones, estuaries, and in full strength, full salinity saltwater areas. Very common throughout the Gulf of Mexico. There's actually Cyclops panamensis is actually in the other ones too. You can find it there. And then you see here's all the other orders of copepods, and the rest of them are pretty much parasites. So here's the developmental stuff. You can see here that this is like a calanoid developmental stage thing. So the calanoid copepods basically broadcast their eggs, kind of like a yellow tang versus like a clownfish which lays eggs. So these guys broadcast their eggs into the water column. The eggs I think they're negatively buoyant, so they tend to sink. Then they hatch. Then you get multiple stages of larval copepod before they go through metamorphosis. Then they reach their juvenile stages and then become an adult. Typically, the females are larger because they got to have room to carry the eggs. And they live longer. The males, once a male reaches full maturity, they no longer go through any more molting. They don't really eat anything. They're just there to reproduce with the females, and then they fade away. Tough. And so see, these are some of the common ones in aquaculture. There are tons more. And so these are just some of the ones I discovered. And you kind of get the sizes of the nymphs and the adults, and you can see here the nauplii sizes are very small compared to the adult sizes, and that's something that people in finfish aquaculture really pay attention to. So this is Tigriopus californicus. These are some of my own images. That's the female on the left. You can see that egg cluster, which is attached to her urogenital segment. And so she just continues to pump out eggs that she fertilizes with the sperm that she stores in her body. And then the embryos mature and they hatch right off of those little clusters. And so the male there on the right, you can see the male has a modified antennae, these little hooks, and they use those hooks to latch on to the females before they go through their final molt. While they're soft, they mate, they reproduce, and then that's it. The female's good. She doesn't need another mating occurrence after that. And then the male just keeps finding females. So it's kind of something that I do my best to encourage in my cultures is reproduction. So when I see egg masses like that on females, that makes me happy. This is a nauplius of the Tigriopus californicus. This is just a close-up. They look nothing like the adult, which is pretty remarkable. These guys like to mill around the substrate in the mulm and eat organic waste and anything that sinks to the bottom of the system. Tigriopus californicus uses in aquaculture. A lot of seahorse people like to use them, but you got to be careful how you use them with seahorses because they tend to crawl on surfaces, crawl on things, and they might crawl on your seahorses and a little bit of stress, but it's not too bad. And then the hobby, feeding sensitive animals like mandarins, pipefish, seahorses that we have in our aquariums, and culturing for personal use. It's really cool that the average hobbyist that really knows nothing about this can culture copepods and learn more about it. You can enrich your life with these animals. So the culture diet, I feed them phytoplankton, and then as the cultures progress, they get a lot of waste organic debris. Very hardy, 21 to 30 days to sexual maturity. It's all temperature and food driven. They're euryhaline, so they can tolerate a wide range of salinities. Eurythermic, wide range of temperatures. And sexual maturity is once it's reached, they're done molting, they're done growing. And then nutritional profile, they're chock full of carotenoids. That's what gives them that color. Fatty acids and enzymes, all the stuff they get from the phytoplankton. Here's another one that I work with, Cyclops panamensis. We call these apex pods. This is the cyclopoid now. You can see here the female carries her egg masses on each side, so there's two of them instead of one. And so this is a nauplius. This is like a stage 2 or 3. And then this is an older nauplius. It's like a stage 4 or 5 or 6, right before they're going to go through metamorphosis. And you can even see the fecal pellet in there. Speaking of feces, so copepods actually produce a sheath around their poo, because their primary diet in nature is diatoms. And diatoms have these little silica spines on them, those little spicular things. And to prevent those spines from destroying their digestive system, they create, it's like a myelin sheath or something. They create a sheath, it's like a sausage. It's like an extruded sausage. And it's coated with this sheath, so it slides right out of them real easy. And it doesn't destroy them. And then that poo is negatively buoyant, and it sinks to the bottom of the ocean and fertilizes the ocean. So there's a lot of that going on in the ocean. If you've swam in the ocean and taken it in your mouth, you probably ate some copepod. So, and then this is the third one that I work with. This is the Calanoids copepod. I got this one from Karen Britton out in Hawaii. It was collected off of Oahu. She's a very famous breeder out there, and a good friend of mine. And I called her up many years ago, and I was like, I need this copepod. I want to make it available to people in the U.S., to people that want to work with more difficult fish like yellow tangs. And so this is an nauplius, very small, and that's an egg. These are all photos that my good friend Jim Welsh took. Very good guy, really was smart, knew a lot of stuff about this. So uses in aquaculture, this species is used in food fish aquaculture, and as well as marine ornamentals. And what aquaculturists love about this animal is the size of that nauplia. This animal right here is small enough that it can fit in the mouth of these small larvae. And these larvae, like yellow tang larvae, are tiny. You wouldn't even believe how small they are. I mean, they're like the size of your smallest eyelash. And so you can imagine that an animal like that, when it starts to feed, has a very small mouth, and it can only eat certain size things. And that's where copepods fall in. And also, copepods contain digestive enzymes. So these larval fish that have this rudimentary gut, this animal helps the fish digest itself, so to speak. And so while the gut is improving and growing, there's digestibility positives about this animal when it's consumed. And then again, this one, phytoplankton, we only feed this one by phytoplankton. It's kind of picky. When it comes to phytoplankton, we don't know what's going on. It maybe can taste, manipulate, I don't know, because live algae has things going on in the cell surface. And so we're trying to work on fooling this animal into eating dead algae. I don't know what the heck is going on. And so we're looking to create a domesticated strain that only eats dead algae. So we start off with 1,000 of them, and maybe 5 of them live and reproduce. There we go. That's what we eat. Selective breeding, so to speak. And these guys grow really fast. So 5 to 7 days of sexual maturity, pumping out babies, and then after about 20 days, the female dies. So I'm going to get into a little bit about the sexual dimorphism. So this is the Cyclops panamensis. You can see the female is there on the left, very kind of smooth, continuous antennae with the little hairs on there, and that's what they use to pick up on currents and predators, so they can evade predators, things like that. And then you can see here the male has like articulations. It's like he's got wrists and elbows, and these little hooks at the end. They have developed that to be able to latch onto the female and mate. And so I discovered this, and I had no idea there was dimorphism in these guys, and so this was really cool to discover. And then the Tigriopus, the harpactopoids, you can also do this. But the calanoids, very difficult. So the challenges that we face in our business, and in many others in aquaculture, is with the phytoplankton, with the copepods, there's always the threat of contamination. And I'll talk about how we deal with that. There's seasonality issues. Even with us, we're growing our algae in Silicon Valley, California. There's abundant sunshine year-round, very mild climate, almost Mediterranean, great place to grow algae, but not when it rains for 2 months. You guys are probably familiar with what happened in California over the winter. We got like the most rain we've had in many, many years. It was absolutely insane. And so our farm was really struggling. We were doing the stop the rain dance kind of thing. So weather can just be a problem when you're relying on natural sunlight. And so, and that goes to, where you can grow algae this way. There's only, certain places in the world that you can do this. You're not gonna, have much success in places like Seattle, where you don't get a whole lot of sunshine. So you gotta pick your spots and grow some algae. Storage can be an issue. We grow a lot of algae and we have to freeze it and store it, and be able to store it and sell it. So we rely on external freezer companies to store some of our algae. The same people that work with like produce and fruit people. Equipment can be challenging. Getting the right equipment or inventing your own equipment, which is basically what we've had to do with a lot of our stuff. Was how do we solve this problem? Well, let's just invent something to fix it. Because there's no textbook, technical book that you can go by. Okay, do these exact things, and you can grow millions of gallons of phytoplankton. It's just not possible. And then life support systems. So yeah, constantly having life support. We feed a lot of carbon dioxide to our cultures because algae needs carbon. They need to create these long chain fatty acids. All of these things that make them tick. They need carbon. So they get that carbon. They get rid of the oxygen. We get to benefit from that. And also we have to feed them nutrient, and we have to regulate temperature, and so everything. We basically created our own life support system with all the bells and whistles and our own computer programming, so it's all in-house, and it's very unique. And then growing the right thing, like you're working with an animal that's new and novel. What do you feed the thing? How do you know what to feed? Luckily, a lot of that work's been done, but a lot of these things are available if you know what you need. But that can be difficult as well. And then scaling up. Anytime you scale anything up, it gets just more complicated. And hiring people can be complicated. Getting somebody to be regimented, doing the same thing every day, paying attention to detail, predicting things, knowing when something's going wrong. These are very difficult things to come by with people in this business. And they gotta love it. You really gotta love this kind of thing to deal with this. I mean, the requirement of perseverance is huge because I forget. There's like a saying: you're not an aquaculturist until you've killed 10,000 fish or something. Something ridiculous like that. And so, yeah, there's a lot of ups and downs. There's a lot of failure, but every failure is a step to success. And so that's how we look at it. So we never give up. We always find a way, and we don't get mad. We don't throw things. We just immediately go to let's figure it out. So biosecurity, I'll talk about the biosecurity. So we have our good friend Hannah here. And replacing the word ciliates with people. Ciliates don't always tell you what they're thinking. They just see to it that you don't advance in life. So ciliate and protozoans are a contaminant that we get in our cultures from time to time. And these are things that are just ubiquitous in nature. We don't even know where the heck they come from. And so we really don't like ciliates. They're really cool. They're really neat. I highly recommend you look up videos of Euplotes, Euplotes. There's videos out there under microscopes. These things are really wild. They look like little animals, but they're not even closely related to animals. And so we do our best to exclude these things, to minimize that. We also do our best to not cross-contaminate the stuff that we're growing ourselves. So as far as biosecurity goes, we have a biosecurity plan in place. This is what most aquaculture facilities have. If they don't, they damn well should have one. They should get one. And so it's basically identifying sources of contamination. So to our facility, sources of contamination are rivers, lakes, streams, ocean. Going to the Monterey Bay Aquarium that's a source of contamination to us. If you go surfing, fishing, sources of contamination. Then suddenly you're a vector. You're a vector of contamination. You can be harboring those things under your fingernails, on your hands. You would have no idea. And then you go to work. You put your hand in the tank, or you put some phytoplankton in a flask, and you got something off your hand into the thing, and you've ruined your cultures. And so we take that very seriously. We don't even allow anybody into certain parts of the farm. Even certain employees are only allowed in certain areas. So let's say the rotifer guy that's culturing our live feeds rotifer animal, he's not allowed to come into the Copepod area, and he and I are not allowed to go into the phytoplankton culture room. And there's just all these important things that we have to really focus on and pay attention to, and we have all of these critical control points that we've identified. We have little hand wash things, and you can clean boots and stuff like that. And so it's all to prevent contaminants from bringing us to our knees. Contamination can be ruined. viruses, bacteria. If you look at the shrimp industry, it was a classic white spot disease was just wiped out shrimp farms globally. It was devastating because people were selling rootstock shrimp, selling larval shrimp all over the world. They were trading, exchanging, and they were giving each other this white spot disease. And it just wiped out shrimp farms. And so we learned a lot from that, and we take it very seriously with filling contamination. And then other recommended foods that we carry that we like to promote are mysis shrimp, enriched brine shrimp, rotifers. That's the little animal I mentioned. Rotifers are a very common live feed organism used by clownfish breeders, and many other marine ornamental breeders use this animal called a rotifer. We grow them. We grow billions of them at our facility. We sell them to people that want to grow them. We sell them to people that can't grow enough of them. And so everything from a hobbyist growing them in a bucket to a large-scale facility growing them in a 1,000-gallon tank. We also like to carry eggs. Eggs are a very good source of nutrition, so we have oyster eggs and fish eggs. And then we also sell copepods that are not alive that are concentrated. And then we'll talk about one more thing that we carry here, and then I'll open it up. So TDO, this is something that's very different from things that we do. So this is a dry food that's primarily was designed for food fish aquaculture, fin fish aquaculture globally. So this food, which is called otohime, it's made in Japan. We buy it from Japan. It's used all over the world in flounder hatcheries, sea bass, sea bream hatcheries, even marine ornamental people are using it. Freshwater breeders are using it for like the government, state agencies that are doing supplementation of bass, perch, panfish in the United States, walleye, things like that. They're using otohime in those facilities because it's a very high quality food. It has very good integrity. It also comes in a variety of sizes for different size fish at different stages of their life. And it's also got krill, squid, fish meal. Those are the main components. All those things really equate to good growth rates and a good healthy animal. And so we've been wanting to carry a dry food for many years to provide something like that to all of those people, and we found otohime. So what we did is we took otohime and we turned it into TDO, top-dressed otohime. So what we do is we top-dress this pellet or granule with a compound called astaxanthin, which is a red carotenoid. That's very similar to what makes those tiger pods red. It's very similar to what makes flamingos' feathers red. And so this compound must come from the diet. Algae produce this compound. There's a freshwater algae called Hematococcus pluvialis that when you grow it outdoors under intense UV, it turns red, blood red, with this carotenoid that helps it protect itself from oxidative UV stress. So this is a very powerful compound. It's an antioxidant. It's a pigmentation enhancer. And so we top dress this pellet with that, and you can see here. Here's a proof, so to speak. So this fish on the left was a picture sent to us by a hobbyist. This is the same fish as the one on the right, but just in different positions. No smoke and mirrors here. You can do this yourself. Trust me, it's for real. So this guy I have no idea what he was feeding his perks. And you can see there in the middle, that's a wild type clownfish. Just you can see the coloration. After feeding TDO for about a month, boom, you get wild type coloration. You get more rich pigmentation. And what's cool about this is the breeders love this too, because the females, that astaxanthin gets passed down vertically into their eggs, and so you get that carotenoid eggs in there with the developing embryos. And so it's a good thing to be in there. It's very powerful stuff. Antioxidants, carotenoids are very good for us too. You eat blueberries and carrots and get these things. It's really good for you. You can eat Phytoplankton. So here's some eye candy. So here's a guy, Gordon Greenlee, a friend of mine, who got his orange spotted flylefish to eat TDO, which was absolutely insane, because this is a coral eater. It's a pretty strict coral eater. But there's certain techniques you can use to get them to this point. This isn't like a fish that came out of the wild and started eating pellets. That's incredibly rare for something like this to happen. But it's proof that you can do it, and they can just ravenously eat this. Here's a video that my friend Chad Clayton, who works for BRS, has his own aquaculture company. He's target feeding scolies, and this was the first time I'd ever seen anybody using TDO to feed the corals, and I was like, wow, that's really cool that it ate it. It's happy, and now a lot of people are feeding it to corals. It's becoming a very popular coral food because of all the sizes that are available. And you can see here, this ever turns on. Here's another time lapse, and And this is all like mucus feeding, so some corals have mucus, and they use it to kind of bring things into their mouth. And corals have a few different ways that they can eat. And then you can see here garden eels. These are just garden eels that are just picking up TDO as it kind of drifts in front of them, and that was pretty surprising to me when I saw that. And there are people that are using it for freshwater fish as well. Flowerhorn cichlids. You can really get a hot red-looking flowerhorn cichlid with this food, and there are many other freshwater fish that benefit from this. Everything from Central to South American cichlids, to African cichlids, tetras, lacostomus. We even have people feeding it to axolotl broodstock, and axolotl, once the babies get big enough, they can eat this. I know a guy who's breeding poison dart frogs that feeds it to the tadpoles, and he's like, it's just really good for them. They love it, and they grow really fast with it. And so there's all kinds of uses for it. My boss even took a package that was expired and fed it to his chickens, and they were egg-producing chickens, and they cracked the egg, and the yolk was red. It was the astaxanthin right to the egg, boom. And he was blown away by that. He's like, it smelled a little weird, kind of fishy-ish, but that was like cool. And you can also use it as a fertilizer. I put it on my bonsai tree sometimes if we have expired stuff. And then this is like a clownfish. For the clownfish breeders, which we sell a lot of product, we do a lot of support for clownfish breeders. This is something we came up with to kind of give them a guide on how to wean your clownfish off of live feed organisms. And in some cases, the TDOA, the powder, which is essentially the size of a rotifer, is being used before metamorphosis, way before they even go through metamorphosis, which is really cool. It's really powerful because, as clownfish breeders know, and there's some sitting here, you want your fish off of these damn rotifers as fast as possible. Once they're on the dry food, then it's the game changer. It's way easier. You grow faster. You can feed them other things. You can start moving them around. They're healthy. They grow quickly, and then you can get them out the door to sell market. So this is something we came up with to kind of give them a general guide. And this is more appropriate for Ocelera supercula, not necessarily the tomatoes and the Clarks and milk strawberries, things like that. We're not sure if this is applicable for them. But it also gives people another idea of what weaning looks like. You don't just suddenly stop feeding rotifers and start feeding the weaning diet. You have to have overlap. And so this just helps you visualize that. All right, that's it. Any questions? Well, good, I covered everything, all right. Well, you can always hit me up at the booth if you have any questions. Yeah.
Chad, so I've just had that experience with TDO for the first time and didn't really realise what I've seen until the clowns, two types of clowns were fed on TDO and the other two weren't, and now I've witnessed it myself and how important it is. And I use it all around the store and the fish. What happens if you feed it to, say, a regal tank? I mean, do you see any change in, is there any, if those animals don't carry those particular pigments, do they show any differences? Really, have you seen it with different coloured species, like those Longiostrus files? Or
Yeah, absolutely.
The intensity, the difference, the change as well?
Yeah, absolutely. The whites are whiter, and the other colors are more rich. You also get a healthier animal. I know people have been able to reverse head and lateral line erosion with the inclusion of TDO into their diet, and that was pretty good. But the health benefits, are pretty vast for all fishes if you can get your fish to eat it, of course. And what a lot of the people that have fish that use this, they like about the product is the different sizes. There's a size that's appropriate for some of the gobies and little fishes that we get in that live in the reef. And then there's larger sizes for triggerfish, big angels and tangs. And so you can feed all those different size fish with the same pellets, just the same dry food, it's just different sizes. So that's been very powerful for people to have access to. And then people feeding it to corals. I know some coral growers that they feed it exclusively to their corals. They feed the TDOA, B1 and B2, and they say that it actually stays in the water column longer, and it stays, it's got good integrity, it doesn't dissolve, and so it's the applications are pretty amazing. Sweet. All right. Thank you very much, everybody. And yeah, give me a